All right, we'll start in a minute, okay? Okay, good morning, everybody. Well, it's not morning for everybody, of course. I imagine we have all sorts of time zones on Zoom at the moment. I'm in Seattle, Washington, United States. So it's 8 o'clock here in the morning, but I'm sure it's all sorts of hours elsewhere in the world. So anyway, welcome to our modeling summer course for 2024. So just let me bring up my slides and then I'll share my screen. Oops, where are we here? Okay.
We have a question. Oh, we had a question. Okay. I guess if you do have a question, do the raise hand button. We'll ask. Someone raise their hand and then put it down again.
Oh yeah, yeah. If you have questions, yeah, you can put your hand up. You can put a message in chat, or you can join our chat Slack channel. Okay.
Or you can just speak up if you're
Yeah,
comfortable doing that. But
yeah, or you can speak. Yeah, that's fine too. Okay, yeah. So welcome again. Is it July the 21st, 22nd? I got the date right. That's good. It might not be July the 22nd everywhere else though, but anyway, it's July the 22nd here. So these are the people who are going to help out this week. Myself, Herbert Saro, I'm a professor of bioengineering in University of Washington. Lucian Smith, who's a senior researcher in my group. Joe Hellerstein is a e-science expert, software developer, and faculty at UW. John Gennari, also a faculty at UW and a specialist in annotation techniques and approaches to modeling. And then the two organizers who've been immensely helpful, Bart Jardine, who's also in my group, and Hunter Robbins, also in my group. So you can welcome all these people to the summer school, and they're going to be helping out this week. So Lucian and myself will be doing the presentations this morning. I have a plan for the week I'll show you in a minute. So these are the people who are involved. We do this every year, and we rotate people around. So this year these are the individuals involved. So what are we going to learn this week? I mean, it's tough to learn a lot in a week, but we'll see how far we can get. So these are basically some of the objectives we're going to try to go for. So what we do at UW is primarily systems biology with a little bit of multicellular modeling. So we use computational methods a lot. We develop a lot of tooling. We have some large modeling projects. We work with experimentalists. So we're fairly deep in systems biology. So I'm hoping this morning to give you a brief introduction to modeling in systems biology. And we have our own tooling that we developed over the years. I mean, I've been developing tooling since I was a graduate student. And it helps a lot in the modeling. It pretty much improves your productivity. It gives you access to things that you wouldn't normally have access to. So our platform is one of them anyway, is Tellurium. This is a Python modeling tool. We have a couple of other tools. I'll show you one tomorrow, and John Gennari will show you another one on Wednesday. They're non-Python. We learn how to use biomodels, which is the models biorepository. Tomorrow we'll learn about some specific systems. These are good motivating examples to learn to use the platform. So bistable systems, oscillatory systems, and signaling networks. you learn some basics of model calibration. Joe Hellerstein will go into that on Wednesday. It'll be an introduction really, but it'll give you a starter in this topic. And again on Wednesday, you'll learn the basics of model annotation. And then on Thursday, we have a unique session, probably the first ever, I think, on model credibility. So it's a hackathon on model credibility. So we have this center, National Institute of Health Center, which is dedicated to reproducibility and credibility. And this is our first year where we're going to do a credibility hackathon. And this is going to be based on looking at a range of COVID models, computational models of COVID, and then looking at their credibility aspects that associated with credibility of those models. Then on the last day on Friday, we have a number of invited speakers to talk on various topics. So that's sort of the plan. First thing you'll need to know is where all the materials are. Let me copy this. Hopefully this works. Let me copy this I'll copy this into Slack and I'll copy into the chat as well, okay? So first of all, I'll copy it into chat and then I'll copy it into the Slack channel. So this is a Google Drive that has all the material. I'll show you that in a minute. The other area thing to look at, if you're familiar with Slack, you may not be, but if you are, we also have what's called a Slack channel. I'll put that again into the chat. This is a fairly new technology. I don't know how new it is, maybe what, 4 years old, I'm not sure, but it's sort of like a messaging system, but it's confined to invited people. And it's good for doing back and forth conversations. And if you have any questions during the week, you can either send them to Slack or you can just send them to the chat. Or if you're brave, you can put your hand up and you can actually talk to us. That's also possible. But I know everybody is probably very shy, so that's okay. But chat or Slack is a good way to communicate. Yes, so let's show you the drive then, I guess. Let me show you the drive. So oops, that's the wrong thing. Let's go, where are we? Here we are. So let me go to the drive. So that link in theory should take you to this page. Okay, this is what you should see. I hope that's the case. And what you see there are the 4 days, day 1, 2, 3, and 4. Materials for each day will go into those days. And then here there's some cheat sheets on our software if you want to download them and use them. Okay, so within one of these, say day 1, there's a whole bunch of material. Okay, so this is where all the material will be kept. All right, so let me go back to my Zoom. Oops, that's my Python. Let's go. Where are we here? I'm sort of lost. Where on earth did it go to? Oh, there it is. Oh, I'm completely lost here. There we go. Here I am. Okay, so there are various things on the Google Drive. There's cheat sheets, various documents on how to use Tellurium. There's various scripts, PowerPoints, and there may be the odd exercise. Okay, so there's a bunch of stuff. You're free to download all those and use them in any way you want. Okay, so there's that material. So these are the topics. Hopefully you can see this. The font isn't very dark, but I think it's visible. This is the plan for the whole week. So we're working 8 a.m. to 12 a.m. Pacific time, Mondays to Friday. Friday, I said, is just invited talks. Thursday is this new idea we have for a credibility hackathon, and Joe Hellerstein will be the moderator on that. Today, on Monday, we have all the basics, introduction to Python and so on. I'll got another slide, we'll talk about that. That's Lucian and myself. Tomorrow, we'll talk about some specific systems involving negative feedback, oscillations, and bistable systems. These are just good motivating problems to look at when you in trying to use the software and learning to use the software. And then on Wednesday, we have some more specific topics like model calibration, signaling networks, and annotating models. Now, the Tellurium documents itself, okay, can be had from here. Oops, let's get that. Let's copy that as well into chat. Might as well put that there, and I'll put it into Slack as well. This is the primary documentation for the software. But as I said, I got a whole load of other stuff on the Google Drive that you can use, okay? Okay. So what is it about the software? I mean, there's quite a bit of software out there for building models, running models, analyzing models. We happen to have our own, which is Python-based. We've had others in the past that were different, but Python has become a very popular platform for working in science and technology. And there are quite a few tools that use Python now in systems biology, and ours is one of them. This is Tellurium, and I should probably put that in here so we know what it is. Tellurium, okay. So those of you who might be curious, why is it named Tellurium? That's because it's next to antimony in the periodic table. And why was it called antimony? Why do we use antimony? Is because antimony, the letters for antimony is SB, and SB we can imagine that stands for systems biology. So that's where it came from. Now, the other thing about this tool and a lot of the other tools, we use this common format called SBML. You'll hear more about that later. But this is the common exchange format. And what that means is you're not limited to just this tool. So you can develop your models on this tool. And then, next week you can load your models into another tool. All right. And there's quite a lot of these tools that use SBML. So you're not limited to just using one tool like it was, 20 years ago. You can now move from tool to tool. And that's particularly important when tools sort of disappear. Maybe funding has stopped or the person's retired or whatever, and the tool no longer works. Well, you can move the models if they're in SPML to another tool that's still active. So this allows your models to continue to work years after they were developed. Okay. Now, the other thing with Python these days is you can either run it from the desktop, all right, and there are various ways to do that, or today you can run it directly from the web. And today we're going to be running it from the web using Google's Colaboratory. Now, the reason we do that is because it avoids any problems with installing Python on your desktop. Okay, sometimes there's perhaps always a few people who struggle with installing. There's something not quite right with their computer or whatever. And to avoid that, we're going to do everything on the web. Now, that doesn't mean you have to then do everything on the web from forever. I'll mention some tools to you on the desktop that you can use. I primarily use the desktop to do all my modeling. But for convenience today, we'll use Google's Colab. We also use Google's Colab in classes too. So we have some classes in the fall and after the winter. We also use Colab there too, just because it's very convenient. Okay, so we'll talk about Colab when we get to it. Oh yeah, this is a list of software that you can use on your desktop. Some of these you probably know about, and I'll show you some of these later. I'll show you one of them anyway later. Is it the Thorny, not Thorny? Thorny. Let's fix that. Thorny is an interesting one. It's a newish one. It's completely self-contained. You don't have to do anything. You just download it and install it. Works on any platform, Linux, Mac, or Windows. And then it has a little GUI to help you install, the various packages that you might need. So that's a really easy one to use. Spider is another one that's geared more towards science. PyCharm and Visual Studio Code, although they mainly software developer platforms, they're also good for running Python on. So There are various tools you can use, and I'll talk about, I'll show you Spider later on, just to show you what that looks like. But as I said, to keep things simple, we'll be using Google Colab. And so one of the first things we need to do is to get you onto Colab, okay? So I'm going to take this link. So we're going to have a 5-minute pause here, okay? And you can ask questions as well at this point. But we'd like you to try to get logged into Colab, okay? All right. So I'll give you 5 minutes or so to do that, all right? If there are any questions, just ask, okay? So you'll need an account, but let me show you what it looks like. If I take that link myself, right? Okay, it does a search for some. Oh, because I had a C in front. Okay. Anyway, you'll find Colab. If you go to Colab, you'll get to this site. All right. Now I'm already logged in, and I think you need to have an account to use this. But you'll see a page like this, okay? And in this page, there's a little bit on, how it works and so on. You don't need to worry about that. But up here, there's a menu. And in the menu, you'll see various things here. And the first one is File. And this is the one you want to look at. You want to look at New Notebook. Okay.
You have a question.
Oh, yeah. What's the question? I can't see, so.
Hi, sorry. I'm just wondering whether it's best if we copy the materials to our personal drives in order for us not to mess up any of the code that's
you
we're
can
going
do
to be
that if you want.
Right.
Yeah, you're welcome to do that. Yeah, you can copy that material down if you want. No problem.
Thank you.
Yeah. Let me see. I'm not sure what the difference is between new notebook in Drive or open notebook. Let's try open notebook, see what happens. Okay, those are existing notebooks. Okay, so let's do a new one then. So new. Okay, this is doing what it's supposed to be doing. Now, what it may be doing is storing. If you have a Google Docs or if you have a Google Drive, it may end up storing this on your Google Drive. Okay, because this is a Google technology. Anyway, this is what it should look like when you type new, and you can do this as many times as you want. Okay, open up a new one. Okay, all right, if you like to. All right. And this is what it should look like. And just to test it going, we can all try this. Hello to class. You can type whatever you want here, of course. So I'm just going to get it to print a message. So you'll see this gray strip here. That's called a cell. All right. And this whole thing is called a Jupyter Notebook interface. All right. Those of you who have not seen this before. And it works through these things called cells. Now you can have one giant cell, right? Or you can have lots of little cells, but that's entirely up to you. But here I've got a cell with just one line in it, and this one line says print hello to class of 2024. Now, if I want to run this line, I can do one of two things. I can either, the easiest one is just go to this black arrow here, this black thing here, this little white arrow, and press it. Now, there'll be a little bit of a delay to begin with because it's having to start everything up. But there you can see the font is rather small, but it says there, hello to class of 24, okay? Now, those of you who know notebooks will also realize the other way to do this is to go hold down. If you don't want to use the mouse, you can go Shift Enter, and that does the same thing, okay? But if you can't remember that, just click on the little arrow there on the left, okay? I can put in another cell here. Let's put in let's assign a value to some variable A. Oops, I didn't want to do it that way. Then I'll print out A. Okay, and then press the button, and I get 5.6. So you notice here that I can have more than one line in a cell. As I said, if you really wanted to, you could have one giant cell with all your code in one strip of gray. But often what people do, they have little chunks of code in the different cells. Okay, all right. So hopefully you're able to get yourself set up on Colab. We'll come back to this in a minute. All right. Okay. Go back to here. Oops. All right. Okay, I think we've done that. Okay, so day one plan. This is our plan for today then. All right. So we have a welcome message. 25 minutes. That's not bad. We're almost still on time. So I'm going to do a little introduction to Python. I don't know how long that's going to take. Some of you know Python. If you do know Python, you can go away, have a coffee or tea or whatever, and then come back. But those of you who don't know Python, this is a chance for you to get some basic Python for yourself. Okay. And then we'll have a 10-minute break. And then we'll have a lecture on modeling. And then Lucian will have a little introduction to antimony. And I think, Lucian, you'll probably start up tellurium, right, at this point, I guess.
Yeah.
Yeah, okay.
Because it'll all be in Colab, so
yeah, okay. So he'll show you how to start up tellurium as well, and then he'll talk about antimony a little bit. And then we'll have another break, and then I have a lot of examples to show you, and one exercise on various ways to do modeling with tellurium. And then Lucian at the end will introduce SBML and biomodels and how you can use those in tellurium. Now, the timing, we'll see how well we do on the timing. We may go over. If we do, we'll stop at 1 though, and we'll continue tomorrow. Okay. If we finish early, we finish early. And if we do finish early in there, we can have questions and so on if we finish early. But we'll be fairly flexible on the timing. Okay. Oh yeah, one last thing. Yeah. So many of us probably have been trying out these new AIs, things like ChatGPT and Claude. These are these new large language model AIs. These are sort of, everybody's talking about these. And you'll find that both ChatGPT, especially ChatGPT, I think, Claude too, are well acquainted. They understand tellurium and the model language antimony. They seem to know it quite well. And I'll show you one example of using ChatGPT for modeling. It was quite a surprise to me. I just did it the other day. We use this on and off to do various things. We use these AIs to do various things, but in preparation for this, I did one thing. I thought I'd ask it to see what it did, and it actually answered it correctly. So I want to show you that because I was quite surprised by it. You have to be careful though with these AIs. They're very tempting to use, and I use them a lot for various things, but they do make mistakes. Okay, so be very careful when you use them. I've used other ones. I tried other ones like Perplexity and Find. They seem quite knowledgeable, but Copilot was pretty bad, and most of the others were pretty bad. I haven't tried them all, but a lot of the others I tried weren't very good at modeling. So I was surprised that Copilot didn't do very well, which is Microsoft's AI. But anyway, I'll give you an example later on, which might surprise you. Okay, and I think that's it. We come to the end of the introduction. So, any questions anywhere? You okay? Where's chat? Oh, here it is. Otherwise, we can move on to Python. So I picked up this slide. The slide I just used, I just picked it up from here. Welcome slide, okay? Maybe I should show you some of these. This one, I don't know what this one shouldn't be there, but anyway, leave it there for the moment. Got a couple of things here. We got some there's some slides I'm going to use on modeling, this introduction to modeling. This is the introduction to Python. There's a biomodels demo there. There's a little short series of slides on tellurium. This is the big slide deck on using tellurium, and they have an antimony demo down there. So these are all the slides we have. And there's at least one exercise in one of these so that we'll try as well. Okay, so let me go to Python. So you'll notice that some of them have this one at least, and the other one should as well, but it has this little symbol here, this funny little orange symbol. That tells me it's a Colab document. And if I double click this, it'll actually load it into Colab. So Google Docs understands Colab or Python files. And this is why we use it in class, of course, because we can copy all our exercises and so on into a Google Drive, and the students have access to it very easily. And that's what I just did here. I just double-clicked on Introduction to Python, and it loaded this. So this is a deck, or this is a notebook that pretty much introduces Python. So, okay, yeah, somebody's asking what's the Google Drive link. And somebody got that? They can, let me see. I have it here. Here it's in the welcome
have it.
drive here. You have it? Oh, great. Thanks. So we'll copy that in again. Okay. So this is going to be a quick introduction to Python. Now, the good news is you don't need to know much Python at all to use our modeling platform. In fact, in the extreme sense, Python is very much in the back seat. In fact, you could do modeling with only knowing 3 things about Python, and you could do all the modeling you want almost. But of course, if you do know a lot more Python, you can do a lot more with it. But as I said, there's not much you actually need to know to actually do some useful modeling. So, but I'm going to teach you more than a little bit you need to know. So we're going to do a few more things. So let's begin with the first. So we'll start with the first cell. Okay. So as I said before, these gray things here that you see, these are called cells. All right. Now the other thing, you may be noticing these white strips. So these white strips are where the output appears, but it also is where you can add text, not Python, but text. And if I, for example, there's a little title here. So let me, I can edit this white strip. So by clicking on this little pencil, right? And let me just delete that. And I can sort of basic Python types, right? I can type that. This is just text, nothing else. And I have a little toolbar here. I can ask it to spell Python, right? I can ask it maybe to do some editing on the changing the style of the text, and then when I click this, close the pencil button, I get a title. So this is why people like Jupyter notebooks, because they can mix text like this with code. All right, so you can put something together like this for a class, and it'll mix up code with explanations about the code and various other things. So that's why people like this. And the other thing is you can now send this to somebody else, and they have all the code plus all your notes. Okay, so that's why people like notebooks. And we won't be doing any more with this, but for those of you who are interested, oops, I didn't want to do that. I don't know how I did that. Let's go back to here. For those of you who are interested, you can also type, this is basically Markdown. For those of you who know Markdown, it's a specific format. But I can put in equations here. If you know LaTeX or LaTeX, you can put equations here as well. Okay. And if I do that, now I get y equals x squared. Okay, so it's basically Markdown with LaTeX extensions. If you know LaTeX extensions to do math. So it's quite nice to have. Okay. Okay, somebody would like the link. Okay, there we go. All right, let's start then. So the easiest thing to do is, how do I print stuff? Well, you print stuff by typing print. Okay. And here the first line is print welcome to so-and-so. And as I said before, to run this line, you just hit the button there on the left. It takes a little time to spin up. Once it's spun up, then it's ready to go. So I just printed out the message. Now this thing in green here, that's a comment. It doesn't do anything, but you use it to add some text to your code, okay? And to add a comment, you just put this symbol. This is a hash symbol in front, and it's a comment. Okay. So here's another cell. I've got here a comment. This is a comment. It is not executed, and then print some more stuff, and it then prints some more stuff. Okay. Now, as I said before, cells are executed either using Shift Enter or the black arrow button on the left. All right, you can do either. All right. If any of you use Mathematica, Mathematica also uses Shift Enter to do that as well. Where can you get help? All right, where can, you want help on Python and so on. Well, Google, of course, is always the place to go. There's another place called Stack Overflow, which can be useful too. Okay, so there are lots of places you can go for help. Okay, so one thing you notice in the print is the message is in quotation marks. Okay, can you see that? The message is in quotation marks. And this is an example of a piece of data that Python understands. And in this case, the piece of data is what's called a string. It's just a piece of text, okay? So that's one kind of piece of data that Python understands, and that is just text, all right? But there are lots of other pieces of data as well it understands, and this is a list of some of them. It understands integers, floating point numbers. It has a thing called a list, which is just a list of stuff, and this is a list of numbers. Now, once you have these types of data, you can obviously do things with them. In this case, I'm assigning the values to a variable, right? And I hopefully you have some background in programming that this is familiar to you. But a variable is just a name or something where I can store a piece of data, okay? So I'm storing 2.3 in X. So if I go down, let's start a new cell. So I can start a new cell here, and I can ask it to, let me run this first. And I can ask it down here to print the value of, let's say, what should we print the value of X? Okay, and I get 2.3, all right? Now, once you have values in variables, you can do things with the variables. Here, I'm just adding two variables together. So if I print X plus Y, okay, I'll get 7.8, okay? Now, lists are also a very useful way to store data. They're really easy to create. So I'll create a list called X, and I'll just call it my list, okay? Equals, and then square brackets, and then whatever you want in the list. Okay, it can be whatever you want. And that's the list. Now, lists turn out to be really useful. That should be my list, I guess. Okay, and then I'll print it out as well. Oops, I keep hitting that. Print my list. And it prints out the list. Lists turn out to be quite useful when you're doing modeling, because lists form the basis for representing data. Lists and a very related thing called arrays, they form the basis for storing simulation data. And lists in particular also are a means for repeating simulations many times. Okay, so they will come in actually very handy. So you don't need to know much about lists, other than this is one thing you need to know, how to create a list like this. And there'll be one other thing you'll need to know in a minute, but actually maybe I can do it here actually. There's a thing called range. And what range does, it creates a list. By the way, did you notice when I hit the brackets, a little window popped up? That's, in this case, it's not a particularly good help, but it generally comes up with a help. All right. And this applies to Tellurium as well when we do it. So helps, you can get a lot of help in a notebook. It tends to pop up. But this thing produces a list. And if you see here, it requires a start, a stop, and a step. So if I could stay start, stop, and then maybe a step. Okay. Now, if I print X, you won't see much. Oops, what happened? What did I do wrong there? Oh, step must be that. Yeah, that's right. It's got to be an yeah. And now if I print X, it just repeats to me range 0, 10, 2. What it's trying to do here is it's trying to be efficient and not give you the entire list, because I may have done this, which would be a huge list, and it's trying to be efficient by not actually giving the list. I can force it to give the list by typing list in front of it, and then it'll actually give me the list. And there's the list 0, 1, 2, 4, 6, 8. Okay. Now I could have done this, right? And things would have been a rather big. I'll just do that. There it goes. There's a long list. All right. So you have to force it to print the list by using list. Okay. But anyway, list will come in handy later on. All right. So okay, so the next thing is the various arithmetic operators. Let me go back to this cell and I'll type in some numbers. Okay. So you can do the usual things. I can do addition, I can do subtraction, I can do division, and I can do multiplication. Okay. Make sure I type print properly. And run. And all those operators work. Okay. The one that you may not be familiar with, if you're coming to Python, if you're new to Python, is the power operator. Now, in some languages, you would type something like A to the hat B. All right. You don't do that in Python. And the reason is because Python is a fairly old language. And in Python, you have to type star star. Okay. And that's the power operator. So if I run this, you'll see we'll get 16. Okay. So that's the power operator. We won't be using that too often, but just to be aware of it. Printing, we've already done, but you can print lots of things at once by just having commas between them. All right. The names of variables, I've been using some very simple names like A and B. That's not always a good idea. It's always better to have a longer name so you remember what you were trying to store. Yeah, I got some longer names. These aren't very good either, of course. I'm just calling it my number, which really doesn't help anybody. It might be better if I said something like concentration of ATP, maybe. All right, so now it's pretty obvious what that is, okay? So, anyway, I could store all my data in these variables. This is what's called an integer, where it's a whole number. A float is something which has a fraction attached to it. A string, which is just something in double quotes. Python, like most languages, also have what's called Boolean variables. These are true or false. Okay, so that's true. And I come back again, I got a list. Notice this case, a list has a list inside it, which also has a list inside it. Okay, so that's one of the useful things about lists. We won't be using this much, but lists can have lists inside them. You can imagine that if you wanted to represent a matrix, for example, you might have a list of rows or a list of columns. Okay. Funny thing about lists is you can add them. So, and they will basically combine together. So I can add oranges and apples and protein and carbohydrate. I can literally add them together and they'll form one big list. Okay. The same comes to strings. I can add up strings like this and it basically combines the string together. Okay. What about more complicated math, like logs and trig and so on? So this is where we come into libraries. So one of the things that people like a lot about Python is it has a huge number of software libraries. And Tellurium is an example of one of those software libraries. Okay. And one of those basic libraries is the math library. And this is what will provide all the trig and the logs and other mathematical stuff. Okay. And to use a library, you have to use this statement import. Okay. All right. Now let me leave that out for the minute and let me just say import math. If I import math, the math library is now ready for me to use. And to use it, I have to type the name of the library. And notice the minute I type the name, the help came up showing me all sorts of things that I could perhaps, that I meant. I did mean math. And then let me do this. Then I hit dot or period. And that brings up all the things in the math library. Okay. So some of these you'll recognize: square root, tan, log 2, log 10, and so on. But here I'm just going to use cos, cosine, and I can get the value for the cosine. All right. So math libraries are heavily used in Python. All right. This is also an opportunity to tell you something about help. Let's say you're typing, oops, math, and you find something you like, but you're not quite sure what it is. Let's say com. What is com? So if you want to know what com is, you can just put a question mark and then run that, and it gives you all this information. It says you this is basically combinations, all right? It gives you the number of ways to choose k items from m items without repetition and without order. So it's very useful for getting help. Now, I brought this up in a new window called help. To get back to your notebook, just click notebook, and you're back there again. So whenever you're in trouble and you see a method you think you want to use, but you're not sure what it is, you can just type the method and type a question mark, okay? And it'll do it. So the original one I had was pi. Of course, we all know what pi is. And in fact, it doesn't tell you much at all. Actually, that was the wrong one. What did I do there? Why is it giving me? That is strange. Hold on. Let me kill all these. I'm not. Oh, yes, I see. Yes.
String form is right. The doc string is just wrong.
Actually, this is a Python issue because it doesn't know what pi is. It just sees pi as a floating point number. So I don't know what this red line is. It just sees pi, which is, the circle constant. It just sees pi as a floating point number, and it just says, hey, it's a floating point number. But it is odd that it does this, though. So anyway, okay, you'll just have to know what pi is, okay? So it doesn't give you any help on pi. But anyway, we can print pi anyway. There it is. There's pi. So yeah, we'll be importing libraries a lot, and one of the libraries we'll be importing is Tellurium. Okay. Okay, so that's a lot of the basics for Python. In fact, I mean, there's not much more you have to know to do some modeling. In fact, you can get away with just this. What are the variable types? The most important are integers, floats, strings, and lists. All right. I wouldn't even count true and false in that and in the essential list, but those. And the other neat thing you need to know about is how to import a library. And the other thing you need to know is how to call something in the library. You can get away with just knowing these things, right, to do some modeling. Now, if you know a little bit more, of course, you'll be able to do a lot more. And I'm going to show you a couple of things that will be useful to you. I'm not sure what this red line is here. I don't know where that came from. But anyway, I don't know what to do with that. Okay, so there's a couple of things here that are useful to know about. One is loops, right? In other words, repeating things. And we'll be using loops later in the morning when we're doing parameter scans and things like that. So I want to mention a little bit about loops. So, and loops require the use of lists, which is why I introduced lists. All right. And so here's a loop. That's a very simple loop. All right. So this loop will loop 4 times. All right. And there's a couple of things to focus on in this loop that are really important. First thing, the loop statement itself. So the loop starts off with 4. All right. Then it has what's called a loop variable. Then it has the word in, and then it has a list. All right. Now what that means is it wants to pick out one number at a time from this list, put that number into I, and then execute whatever is underneath the 4. Okay. Now, two things to notice. Number one, really easy thing to forget is there's a colon at the end. Notice that there's a colon at the end. All right. The other thing to notice this gap here. There's a gap. That's called an indent. And that tells Python where all the instructions are that should be run in the loop. So let's take those out for a moment. And let me just run this. Okay, so this is the simplest possible loop you can have. And let's add a few more here, shall we? Let's do 5, 6, 7, 8. If I run this, you'll see 1, 2, 3, 4, 5, 6, 7, 8. So it's running this loop 8 times. In other words, it's running what's inside here 8 times, and what's inside there is print. So it's printing I 8 times, and I gets a new number every time it goes around the loop, and that number comes from the list. Okay, number comes from the list. Now I could have whatever I wanted in this list, of course. I could have a floating point number. I could have a true. I could have a string. If I do that, you should get what you expect, right? It's pulling these things out of this loop one at a time and printing it. So it's 1, 2, 3, 4, 5.6, true, ABC, 8. All right. Now, the important thing though is this indentation. If I don't do the indentation, it won't work. In fact, it tells me there's an error, indentation error, expected an indentation block after 4. Okay. So it really expects something to do after the 4. Now, it doesn't matter how many spaces you use in the indentation. That doesn't matter. I could use 1, or I could use, 20. It doesn't matter. There's got to be some kind of indentation, right? Oops. Okay. Now, I can add other lines to this, of course. I could add another one. Let's do I times I. This is going to be interesting because I don't know if this will work, because I'm not sure. Actually, it probably will work, actually, although I'm not sure what it'll do when it comes across the ABC. Let's just see what happens. Ah, yes. Okay, so there's an error. Now, I asked it to also print I times I. So, for example, 2 times 2, 4. It's okay with that. It multiplied true by true, gave me true. No, it gave me 1, sorry. Was that what is it doing? 5.6.
Yeah, I gave you
Oh,
one.
yeah. Gave me 1, yes. All right. I don't quite sure what. Oh, yeah. Because I'm printing 2 lines at a time. Let me get rid of this. This is confusing me. Let me get rid of that for now. There we go. Okay. So I'm getting 1, 4, 9, 16, right? That makes sense. And then 5.6 times 5.6 is 31.3 something. True times true is 1, amazingly. But ABC times ABC is an error. So you can't multiply strings. I can add strings, of course, although I'm not sure if I can add, I think I can add floats too. Yeah, I can, I get a 2. So I'm adding ABC together with ABC and I get ABC. All right. So you got to be careful, what you do with these operations. Some are legal, some are not. Let me go back to this one. And what I'll do is I'll do this, I'll pull this first line so we can see what's what. And I'll put second line, oops. And I'll do I plus I, the capital there. And I'm going to get rid of the true of the ABC because I just don't want to have an error. There you go. Now, if I run this, I get the 2 lines. So notice that the second line is also indented. There's 2 things to watch out here. If I'm inconsistent with the indentation like that, right? Like the second line is indented differently from the first, that will cause problems. cannot do that, all right? Whatever indentation you use, stay with it, okay? The other thing, if I take this right back to the beginning, I won't get an error, but it'll only print the first line, right? And it prints the second line once right at the end when it comes out. So in order for something to be part of the loop, it has to be indented along with the other one. Okay, now if I do that, it works. Okay. Now the reason I've been dwelling on this is because this applies to a lot of other things in Python. The colon is often used like this, and the indentation is always used when you want to block or group things together like this. Okay. All right. So that indentation is important. As I said, it doesn't matter how much you indent. You just got to make sure that you indent consistently. Okay. All right. So here's a little note here. Python indentation is a way of telling Python that the group of statement belongs to a particular block of code. Okay. All right. So here's a lot more complicated one. I'm going to get rid of this. Actually, I can't get rid of it, can I? Never mind. This is a more complicated piece of code. All right, let's see what this does. So I'm creating a variable called sum, and I'm setting 0 to it. I'm printing that value out, I guess, just to make sure it's 0. Then I'm starting a loop for I, just to show you, I'm going to change this to ABC because it doesn't matter what I call it. I'm starting a loop for ABC in 1, 2, 3, 4. That means that this loop will go around 4 times. Each time it'll put the number into ABC. It'll take the sum and add ABC to it, and then assign it back to sum. And then it prints out the sum. If I run this, I get what you expect. In fact, let me just put one other number in just to show you. If I put a 5 in, print out the sum. So basically, it's adding up the values in the list one at a time and printing out that value each time. Okay, so there's a simple example. Now, the number of lines you can put inside here in a loop is probably, I don't know if it's infinite, but it's a lot. I'm not sure if there's a limit at all, but you can put as many as you want, okay? Now, it can be a bit tedious to use this kind of list all the time, where you're actually literally typing the numbers. And so, as I mentioned before, there's a special function called range, and that'll create a list for you, okay? So I've got a range here, 10. This creates the list 0 to 9, right? It has 10 values starting at 0. So that's why it only goes up to 9, okay? Yeah, notice that the list starts at 0. So this is used a lot. Instead of literally typing the list like this, we just type in range 10. And I know the 10 means this list will go around 10 times, okay? So if I run this, it'll run this 10 times, and it basically sums up the values in the range until I get 45. All right. Now the range, and I showed this before, actually, the range can be more complicated. I can give you a to start number, okay, and an end number, but the end number is not the end number, it's the end number minus 1. So if I do 2 to 8, I'll actually get 2 to 7, right? I can also, if I want to have a list that goes up in steps, I can do the same thing. I can add a step. So this range goes from 1 to 20 in steps of 2. Starts at 1, but only goes up as far as 1 minus 20, so it only hits 19. Right? If I wanted to get to 20, want to actually hit 20, need to take that to 20, 21. No, actually got to go to 22 because of the step. And oh no, that's not going to work at all, of course. Yes. Let me do it this way. If I do a step 1 to 20 step of 1, this goes to 19. If I actually want the 20, I need to add one more to the 20, then I'll get 20, okay? So that's just one little thing you have to remember. But it's pretty easy. You can do steps here. like that. All right. Okay. And here's one that does even numbers from to 20. So some of you may be thinking, what happens if I want to do floating point numbers? Like I want to go from 1 to 10 in steps of 0.5. That won't work. If I do that, you'll discover you get an error. So if I want to go from 1 to 10 in steps of 0.5, it won't work. It's an error. And there's another, you cannot do floating point numbers with range. It only accepts integers. So you can imagine there are many cases where you'd like to go over a range of floating point numbers, right? Well, there's a special function for do that. We'll come back to that towards the end, okay? So you can't do this with range. All right. That's pretty much all you need to know about loops, actually. I don't know if there's anything much more at this point you need to know. But with that information, you can do a lot more. You can now do iteration. You can scan over parameter values. You can do all sorts of things, right?
I'd say like the only other thing is just that you can loop over an existing range. So you don't have to like define the range in the for I equals whatever. You can say I equals some range and then for I is.
Yeah, you can go my range equals range. Let's do oops, 5. Okay. And I'll go for my value, just to show you I isn't the only one you can use. My value in my range. Don't forget the colon. Hit return. It'll indent for you automatically, noticed. I didn't put that indent in. It did it for me. And I'll print out my value. And that'll just work like that. Okay. Yeah. So you can do that too. All right. Okay. Now there's a couple of other things I've got here. Which sometimes some of them are more important than the others. The if statements, which are the conditionals, are not so important for us. I'll show you one here just so you're aware of it. If statements let you do tests. You can test something. All right. So in this case, I'm assigning 6 to A. Then I'm saying if A is greater than 7, right? So that's the greater symbol. Notice the colon again. If A is greater than 7, then do this, else do this. Okay, that's all it is. And you'll see a pattern here. There's a colon, there's a group of statements with an indent, right? And in this case, though, we have also an else with a colon and another indent. And it's a very similar model to the for loops. It's this time it's an if and an else, okay? It's newcomers, people who are new to Python will often leave out the colon by accident, and then you get an error, but at least it's telling me expected colon, okay? So it reminds you, don't forget the colon, right? Easy one to do, that is. And it does that. So we won't be using if statements much, if at all, I don't think. I'm not sure if we will be at all, but it's worth knowing about. The big one are the lists, though. We tend to use lists quite a bit. So let me go over a couple of things about lists that'll be useful to you. Here's my list. L equals 1, 2, 3, 4. I can add lists. Right? That's a useful thing to know, adding lists. And as I said, lists can contain names, right? So I could put ATP, ADP, right? That's one list. We'll call this L1. And then I'll call the next one L2. I call that AMP. All right. And now I can go L1 plus L2, and I'll get all the nucleotides in one list. I have at least one example of this in one of the modeling examples. Okay. What if you wanted to know how long the list was? You just use this thing called len. We'll print out how long the list was. In this case, the list is only 3 long, so it tells me it's 3. Okay. Another thing that we will use a lot, well, not a lot, but a bit, is appending values to a list. In other words, to make a list longer and longer and longer and longer. The place where I got an example where I use this is when I'm constructing XY lists to plot. So I'm going to plot X data versus Y data, and I'm going to create this list during the simulation. And in order to do that, as the values come in from the simulation, I append those values to the list. That's the reason for knowing about append. All right. There may be better ways of doing this than using append, but it's an easy one to do. So this is an interesting thing for you. This is an empty list. Just square brackets without anything is empty. In fact, let me create a new code here. Here, create a new code cell. L equals empty. Print L. And all you'll get is empty, right? Nothing there, okay? And what I can do though is I can use this append. I can go append 1.2. And now if I print L, it's added 1.2 to the list, right? Let's get rid of that so don't confuse it. I now get 1.2. I could also append math.py. Is it pi with little? Yes, pi lowercase, right? If I run this, I get 1.2 followed by pi. Okay. And in fact, you can append whatever you want. You can append strings, other lists, and so on. But in the examples we'll be doing, we'll just be appending numbers. Okay. So very useful thing to know to append numbers. There's a complicated thing here, which you don't really need to know for our purpose, at least not today anyway. This is something called slicing. I'm not sure if I want to go over this because if you've never seen this before, it can be quite confusing. But it's a way of extracting pieces of a list. All right. So if you have a very long list and you want to extract a piece from that list, you can use something called a slice. This can be useful when you're dealing with matrices and you want to extract a column or a row or a set of rows or a set of columns. That's where it becomes really useful. Now, I don't know if I want to go over this or not. I think at this point I'm not going to go over it. But if you look at this, it can give you some idea what I won't be using slicing. But if you deal a lot with matrices, like two-dimensional lists and two-dimensional arrays, slicing can become quite useful to know. So I'm going to leave this for now, okay, if that's okay. And deleting from a list, I'm going to leave out as well. But obviously, you can delete things from a list. Well, not obviously, but hopefully, you can delete things from a list. We won't be deleting things from lists, but you can delete things from lists if you want to. The other thing worth knowing, although we won't use it either, is defining your own functions. Remember I talked about the math.cosine? Well, you can have your own functions if you want. Here's a simple example. It's a function that adds two numbers together and then returns the result. To do that, you start with the word def, meaning define a function, have the name of the function, have the things you want to pass to the function there, and of course the all-important colon, don't forget the colon, and then a bunch of lines that are indented as usual, okay, in the function. And then if you want to return a value from the function, you just go return the value. So if I run this, I now have a thing called my function, and my function takes two arguments, as they're called, arguments. I give it 2 and 3, and it gives me 5, of course, because 2 plus 3 is 5, okay? We won't be using functions, but for those of you who are interested, that's how you create functions. And the two big ones that you need to know about are plotting data and arrays. Now, Tellurium has its own plotting functions because plotting in Python, there's a little bit to learn before you can do some plotting. So we gave a very simple way to plot in Tellurium. And so you don't really need to know how to do plotting with Python. because we provide a simple plot function with Tellurium. But if you want to do more sophisticated plotting, then you often have to know how to use the plotting library inside Python, okay? And so this is what this is about. So to begin with, the plotting library has to be imported, and it's quite a lot of stuff to type just to get the plotting library in. I'm not sure who designed this, but you have to unfortunately remember this. I eventually remembered this, but often you have to look this up. But to bring the plotting library in, you have to go import matplotlib.pyplot. That is quite long, and so we often add this thing at the end as PLT. That basically shortens that entire thing to PLT, okay? So this is one reason why we added our own plotting function, because this is just a lot to remember for somebody who's new. But anyway, that's what it is. The plot itself is fairly straightforward. It just takes two lists, the list of X values and a list of Y values. Okay, and I've just put in some random ones here, and it'll plot a line graph. Okay, that's quite straightforward. All right. In fact, what I can also do, I can add another plot here. Let me cut and paste this. And I'll put in some different values here. I had to put the same number of values, of course. Let me just do that. And if I run this, do two plots in a row, what did I do wrong? I don't see, I don't see the error. Where's the error? Oh, okay. This is one of the dangers of notepads. Why doesn't it recognize PLT? It says name PLT not defined. You have to be very careful with notebooks. Notebooks, because they're broken up into cells, cells may depend on previous cells. And of course, this cell relies on the fact that I have previously imported the plotting library, which I have not. So I need to run that first. Then I need to run plot. This is one of the dangers, I think, of notebooks. You have to be very careful. Sometimes you'll be doing a calculation and you're getting the wrong result, and you don't know why. It's because that calculation depended on a previous calculation which you forgot to update. Okay, so be careful with that. But anyway, as you can see, two plots in a row give me two plots, one on top of the other. All right, so that's very convenient. Okay, all right, and it picks a new color as well, which is nice. All right. How about something a bit more interesting? So this is where we're going to bring in another new library, which is really important in Python. It's used a lot in data science. It's used a lot in AI, and that is the NumPy library. Now, Python has lists, but to be honest, they're not very efficient when it comes to numerical work. And so a group of people came up with a special list, which are called arrays. These are very high performance arrays or lists. All right, they're not lists; they call them arrays, and they're very high performance. So they're used a lot in AI, data science, and so on. And we use them a lot as well. Okay, and the library that's used to do this one is called NumPy. Okay, oops, NumPy. All right, I guess that stands for numerical pi. And often you'll find people shorten it to NP. Okay, so we will do that a lot as well. So let me run that cell. I've now got NumPy installed. Now NumPy or NumPy has a lot of stuff in it. It's a huge library, but you don't need to know much about it to make it be useful. But one thing it can do, it can create arrays containing random numbers. So I'm going to create a random. I'm going to create two arrays, one called X and one called Y. Let me do the X one first, because that's the easy one. The X one I could have used range here, but I'm going to use a special one that NumPy provides, which is a range. The reason for using this is because eventually this will let you do fractional numbers in the list. So I could actually go 0.5. If I run this, you'll notice I get 0.5s, all right? So range only does integers, but a range will do floating point numbers as well. So it's actually quite useful, okay? Anyway, I'm just going to stick with 0 to 99. That's my x dimension. My y dimension is going to be a series of random numbers between 0 and 1, and I'll generate 10 of them. Is that what I want to do? Let me just run this and see what, let me just run this and see what it is. Let's print out y, what is it? What have we got here? Yeah, that's 10 numbers. So, so that's printed there. That's given me 10 random numbers between 0 and 1, okay? Now, these arrays are not really compatible because I got 100 numbers down here and only 10 here, so I can't plot y against x here. So I'll regenerate them here with the same number of elements, okay? So x is going to be 0 to 100, well, it's technically 0 to 99, and y is going to be 100 random numbers, and then I'm going to plot x versus y, and I think you can see I get myself a plot of random numbers, okay? So that's an example of using NumPy. It's good for demonstration purposes to do this. Of course, you may be asking, well, I really don't like blue. Why can't I have another color? Yes, you can. You can have any color you want, but there are some standard colors that are built in, for example, red. And just to specify the color, you just give the color letter in quotes. This is red. Let me show you green, blue. I can't remember the other colors. Black, I assume. No, oh, that's blue. Yeah, I can't remember what the other colors are, but anyway, red is R. But you can look this kind of thing up.
This K is black.
K, of course, is black. Yes, K is black. There you go.
Sarah has a question here.
Yeah.
Go ahead.
Oh, I see. Yes, I see. Let's have a look at that. Yeah, somebody's asked, why do I have to go random.rand? Why can't I just go rand? And say, yeah, why not? Well, let me do it down here in a new cell. Actually, let me do it up here in a new cell. If I go y equals numpy, rand, and the only thing it gives me is random. So I'm stuck there. So I have to pick random, then another dot, and then it gives me a whole bunch of stuff, actually. In fact, there's yet another random, in fact. In fact, let's just pick that one for the moment. If I put dot again, there are no more. So it's expecting brackets. If I do this, oh, no, let me print y, of course. Print y, let me do this. So it gives me a random number. If I run it again, I get another random number. In fact, I can keep on doing this. You'll notice they never seem to exceed 1. In fact, this random here will generate a random number between 0 and 1, okay? But it doesn't generate a list for me, an array for me. So let's go back and see what else we've got. If I just pick R, it gives me everything starting with R, and you can see there's a whole bunch of them here. One of them is rand, okay? So let's do rand, and let's say you're not sure what this does. I'll then type the question mark. Let me do that. And then it gives me the help. It says it has this odd terminology here, but random values in a given shape. Basically, it means it's returning an array for you, okay? So it's not just returning a single number, but it'll return an array of random numbers. Now, by shape, it means the dimensions of the array. So if I go back to Notebook, so if I just put 10, that means the shape is one-dimensional and there'll be 10 values. Right. If I did, let's say 5 by 5, that shape now is a two-dimensional 5 by 5, okay? So what you see here, though, is a nesting of functionality. So the top level is NumPy, then comes random, sorry, and then inside that there are yet others. Oops, there are others that I can pick, okay? So that's why I had to do random.rand, okay? Because it's a nested library that contains lots of things. NumPy is huge. So all right, is that okay? Why does random names contain 0, not 100? That's a convention. It always starts at 0 and then goes up to, so if I type in, it always goes up from 0 to whatever this number is minus 1. So it'll go from 0 to 99. It's just convention. It's a computer sciencey thing. You just have to live with it, I'm afraid, okay? I mean, I could do, and even if I do this, 1 to 100, it'll still insist on going from 1 to 99, okay? So that's just life, I'm afraid. Takes a bit of getting used to, but what if I wanted to show the actual data points, all right? Then I have an extra thing called marker. This is a new thing here. It's actually named the argument, and then it equals something, okay? Because I don't know if I did this on its own without marker. Yeah, it doesn't know what I mean, okay? So I have to, it doesn't know what that O means. So I have to actually tell it. And then, oh, hold on, that's another reason. Hold on. Yeah, I don't have the numbers set up. So let me do that again. Sorry. Let me set that, and then I'll set that. There you go. Let me do that again. I'm not sure if it'll recognize that as a marker or not. Yeah, it doesn't understand what I mean. Okay. It probably thinks it's a color or something. So we have to tell it this is a marker, okay? And it does it, all right? There are lots of different markers as well. All right? And there's cross and so on. The other thing you might be thinking, yeah, but I can't really see the marker here because it's red against red. I really like a different color. And so there's another little thing you can go marker face color is blue. If I do that, I'll show you because it gives you bigger ones. I get blue markers instead. Okay. But the edge is still red. So I can tell it I want an edge blue as well for the marker. And it gives me edges, a pure blue marker. Okay. All right. What else have we got here? Oh yeah, because last but not least, I can put in my labeling, my x-axis labeling, my y-axis labeling, and you might want to put a title. Let me run this one. Okay, so now I get a nice titles. Title for the plot. I get y-axis title, x-axis title. And I also put this extra thing show. You don't have to do that, but what it does is if I were to do a plot after this, I want to make sure that the plots don't interfere with each other. They're not laid on top of each other. I need to put a show. And then when I start doing a new plot, it'll create a new plot for me. That's all that is. Let's see, what else we got here? Let me see. What's the time? What have we got? Have we got, can't remember what we are on. Let me go back to the, yeah, what have we got here? Yeah, we're probably way over. So, I think I'm going to just finish at this point. Then we'll have a break because it's almost an hour and a half in. Let me just show you this and then we'll have a 10-minute break, okay? So here I'm going to use a new method called linspace. This has come from NumPy. Let me take this on its own. I'm going to cut this. I'm going to start a new cell. I'm going to run this. Then I'm going to print out X. And this gives me a whole bunch of numbers. You notice that this one is slightly different. This tells me from 0 to 2. And now you notice it starts at 0, but it also includes the 2. And this one is the number of values, okay? So this isn't the step anymore, but it's actually the number of values. So because steps, sometimes you have to figure out in your head, well, if I do a step of 0.2, will I get 50 points or 60 points? Like, you know, you have to do the arithmetic. Here you can just say how many points you want, all right? It'll give it to you. So that's why I'm using linspace. So I'm using linspace to create the x-axis. And then I'm going to do various plots. And this shows you one of the powers of NumPy. And it's a very useful ability that NumPy has. First of all, I'm just going to plot x versus x. So let me run this. So I get this plot. So the x versus x is the blue, okay? And here I'm plotting x versus x to the power of 2. That is basically x squared. Now, what's powerful about NumPy is x isn't a single number. X is this entire vector. And so what it's doing here is doing a vector arithmetic. It's taking every element in the vector and squaring it, all right? So this is a very powerful feature of NumPy, is that you can do what are called vector operations. The alternative would be to have a for loop and, you know, work out each element individually. But NumPy lets you do an arithmetic operation in one line. Very powerful. And then I do the cube as well. I'm also adding a label to all these. This will let me add a legend, okay? And I'm doing some titling for the X and Y axis. And then I'm telling it to actually make sure you show the legend. I don't need the print. And then I plot, then I run it, and I get that. That alone, right? This alone will take you a long way to do plotting, all right? It shows you how to, you can create your X and Y data anywhere you want, but it also shows you here how you can use vector operations. It shows you how to add labels. It shows you how to make sure you switch on the legend. And it also shows you how to do labeling, X and Y labeling. This will take you a long way with plotting, okay? Long way. All right. Oh yeah, these are I got a list of the colors here. But I think that's as far as we'll go for now. We'll have a break. You can ask questions, of course, during the break. I'm just going to grab a cup of coffee. But I think after this, Lucian will take over. The only thing I've got here is NumPy.
You want to do the modeling, intro to modeling before my intro to antimony, or do you want to just go straight to antimony?
Sorry. Yeah, I'm sorry.
Yeah.
I'm misreading it. Yes.
That's good.
When I come back, we'll have an intro to modeling. That won't be as long as this. Let's just give you a foundation for the modeling, and then Lucian will do the antimony, okay? Right. So let's come back in 10 minutes, all right? Okay, good. I'll stop. I'll leave this as it is, okay? If you want to look at the NumPy, I'll leave that on the screen. In the meantime, though, I'm going to grab a coffee. So I'll see you in 10 minutes.
And if anyone wants to ask questions here or Slack or chat or whatever, feel free to do so.
Lucian,
Yeah.
should I pause the recording?
Yeah, if you want, you might want to even like just stop it and start a new one and like have different eventual YouTube things, because they're all like some people who are watching this later might want to skip directly to the modeling bit instead of the intro to Python.
Sure. I can do that.